Good morning, guys. Today we're going to go over 6.1, exponential growth and decay. Also, besides this, I'd like to clear a couple of things up, so please listen to the message I give you after the class. So we're going to go over class first, then homework, and a couple of other things I want to clear up. Now, exponential growth and exponential decay are two subjects that sometimes confuse students a little bit, but once you get the hang of it, it's not that difficult. Now, think about the things we produce as human beings. Like, for example, cornflake boxes. A factory can produce, say, 500 cornflake boxes every day. So in one day, I produce 500. 2 days, I produce 1,000 total. 3 days, 1,500. That is linear growth. When you produce in X amount of time, you produce Y units. X amount of times, you produce Y units. Pretty much the things we manufacture are manufactured in a linear fashion, okay? Say, for example, cars, medicine, food transported, money you make, say you earn $3 an hour. In 3 hours, you're gonna make $9. So that's linear growth. Today, we're gonna learn exponential growth, which is slightly different, not linear. It's not linear. Now let's think of, for example, trees. You have one tree, and that tree, let's just say it produces 2 seeds. Now you have 2 trees, and each of these trees produces 2 seeds each. Now you have 4 trees, and each of these seeds produces 2 seeds. Then you have 8, then 16, then 32. You can also think of this as like cellular mitosis, it doesn't have to be by a factor of 2, it could be more. It could be like, for example, mice. Why do mice overrun and cockroaches and insects or ants? Because not ants, because only the queen reproduces. But let's say mice. One mouse can give you 6 little mice, and then these can reproduce and give you a ton more. That's exponential growth. So one thing to keep in mind, exponential growth might start out very slow, but then it rises incredibly fast. Think of the number 2. 2 squared is 4, then it's 8, then it's 16, then it's 32, then it's 64, then it's 128. So again, these numbers are rather small. Then it's 256, then I can't multiply, I'm kind of slow right now, but it goes up incredibly fast. So that's why it has exponential growth, has more or less this shape. Actually, now that we're looking, even though it might not be a subject that is positive, but a pandemic like the coronavirus pandemic, one person can infect 3. Those other 3 can go and infect 4 or 5 each. Pandemics spread out in exponential fashion. That's why we're doing the quarantine. When people don't expose as many other peoples, that's why they mention in the news that we're flattening the curve. We're trying to not make it go up as fast by not infecting many people at the same time. Okay, so again, linear growth, we have the same growth rate slope is the same thing as the rate of change. Linear, like say for example, 1 1 1 1 1 1 1 1 1 1 1 1. Exponential doesn't work that way. It might start off slower than linear, but then it explodes and it just goes up incredibly fast. Now, what do exponential functions look like? Sometimes students get confused. This is a quadratic. A variable to a power is a quadratic function. A value to a variable exponent, that's an exponential function, when the variable is the exponent. Again, quadratic, this is a variable squared, exponential. Okay, they are similar. In this case, at least the quadratic, it's similar, pero when we're talking about exponential functions, we're talking about variables that are exponents. Now today, you're gonna learn to graph a couple, and that's pretty much it. It's a very small theoretical class. Tomorrow we're gonna get into compound interest rate and a couple of other things. Pero as far as graphing go, just the basic rule. Exponential functions look like this. A constant times another constant elevated to a variable power. Okay. Now the rule is a for exponential growth, your a has to be bigger than 0. Because if it's less than 0, that means you have a negative value, and it would cause a reflection across the x, and it would no longer be exponential growth. So your a has to be bigger than 0. It can be 0.0000001. That's fine. That satisfies the a bigger than 0. But as soon as you put a negative, it reflects, and it is no longer exponential growth. It is something else. It is not decay either. It's just something else. So for exponential growth, the rule is your a has to be bigger than 0, and your b has to be bigger than 1. It cannot be 1, and it cannot be less than 1. Let's see what happens if it were the number 1. Let's say I have 4, 1 to the power x. Let's say my x is 2. What is 1 squared? 1 times 4, 4. Let's say my x is 3. What is 1 cubed? 1 times 4, 4. There is no change. There is no growth or decay happening. So your b has to be either bigger than 1 or between 0 and 1. If your b is bigger than 1, let's see what happens when I put the number 2 here. Let's see what happens to my values. Sorry, this moved. Let me make sure it's properly. Okay, that's fine. Now, when my b is 2, if my x is 2, what is 2 squared? 4 times 4, 16. Okay, what happens when it's 3? 2 cubed is 8 times 4, 32. It's growing. So this would count as exponential growth. If your a at the same time is bigger than 0, but now your b is between 0 and 1, I wrote this incorrectly, your b has to be between 0 and 1, or bigger than 0 and smaller than 1. For example, this. That would be exponential decay. It begins very big and then it starts dropping off. 0.5 squared is 0.25. 4 times 0.25 is 1. So from 4, or I drop down, well, no, not really, but just it's exponential decay. If your b is bigger than 1, growth. Between 0 and 1, decay. If your b is 1, that's not an exponential function. It's just there is no change. It would be a constant. Okay. So again, those are the only 2 rules you need to know for exponential growth, exponential decay. Let's look at the 2 examples given in the book, 2x and 1.5x. If I look at 2x, you say, Profe, pero what is my value of a? Well, if you don't see anything, it's 1. So that's fine, bigger than 0. b is greater than 1, so that would be exponential growth. And I'll show you via graph that it's exponential growth. In here, the same deal. A is 1, because I can't see a number, and that's fine. B is 1/2. It's between 0 and 1. That means that this would be exponential decay. Okay, now let's get to the graphing portion. The book, the 2 examples given in the book, they're asking me to graph this, and they're also asking me to graph this. Why do I put the parentheses? Because if you do this, that exponent only applies to the number 1, not the entire fraction. Make sure you put the proper parentheses, okay? So in order to graph this one, let's begin with my table of values. Normally, since this has not been moved up, down, left, or right, we can use these numbers. I hope you remember that rule. If it hasn't been transformed up or translated up, down, left, or right, you can just use these values. That's fine. Let's see what happens. When this is my x, let's see what my y is. Remember, this table can be done across or up or down. Same deal. Just do it however you want. Let's use the same value. Let's use the first value, -2. 2 to the -2. From the rules we learned with the exponents, we know that since this exponent is negative, I can send it to the denominator in a positive fashion. And 2 squared is 4. So that would be the same thing as 1/4. Now let's do the exact same thing with a exponent of -1, because again, that's my x, that's changing. Negative exponent, I send it down to the bottom in a positive fraction. 0, that was one of the rules, and I'm going to go over it again today. Any number to the power 0 is 1. Profe, but that doesn't make any sense. How can that be? Well, no, quite simple. Let's say I have 2 squared, and under this I have 2 squared. Forget the exponent. Let's look at this. Is a number divided by itself? Not 1, always. Doesn't matter the number. Any number divided by itself is always 1. Perfect. Now let's look at the rules of the exponents. If I'm dividing these two, all I gotta do is subtract my denominator. And what is 2 minus 2? And that is 1. So again, any number elevated to the power 0 is 1. Now I'm going to use the number 1. 2 to the first power is 2, and 2 to the second power is 4. When you graph this in a coordinate, in an axis, you'll see that it begins like this, and then it starts growing. Now in this portion, it doesn't look very exponential, but I guarantee if you continue going up to 5 or 7, it's going to just shoot upward. Bien. That takes care of 2 to the power x. Now let's go over this one. Again, same deal. Hasn't been translated. I'm going to use my -2, -1, 0, 1, 2. I'm going to write this to the second side, -2. Now, there's a couple of ways to view this particular problem. The people who are very math savvy, all you gotta do when you have a negative exponent in a fraction is flip the fraction. There are a couple of ways to visualize this. Again, the mathematical way to visualize is that you have 1 over this fraction squared. I sent that entire fraction to the denominator. Then when you divide 1 by a fraction, you just flip. Because again, it's a division of fractions. Pero the people who don't want to see it that way, to make your life easy, whenever you have a fraction to a negative exponent, you can just flip the fraction like this and make the exponent positive, and that's good enough. Then when you distribute, you have 2 squared over 1 squared, which is 4. Again, 2 squared over 1 squared is 4. That gets rid of the -1. Now, 1.5 to the -1, again, you just flip the fraction inside the parentheses, 2 over 1, which is 2. Any number elevated to the power 0 is 1. When you have 1/2 elevated to the first power, I have 1/2. And when you elevate it to the second power, you distribute the exponent and you end up with 1/4. As you can see, my number is getting smaller and smaller by a factor of 1/2. 4 divided by 2 is 2, 2 divided by 2 is 1, 1 divided by 2 is 0.5, 0.5 divided by 2 is 0.25 or 1/4. Exponential decay begins up here and starts going down. Now, later on, we're going to talk about carbon dating and other things that this is useful for. But at the moment, that's it for today's theoretical class. Exponential growth, exponential decay. Know the rules to see when it's going to be growth. Again, you should know that that's going to be growth, that this is going to be decay, that this is something else because my A is negative. That's neither growth nor decay. Okay, you have to know how to visualize that given the rules. And also, if they tell you evaluate, for example, if I say 6 2x, evaluate the expression when x equals 3, all you gotta do is substitute the x for 3 and give me the answer. 2 cubed is 8 times 6 is 48. That's it for evaluating, because part of the homework will have you do that. Now, in today's homework, you do have to graph. I do want to see the 2 graphs I will assign. So again, in today's homework, you do have to graph. The homework is, or actually 3 graphs. From 3 in page 300, the homework, page 300, from exercises 3 to 11. This includes 3 graphs. 2 are exponential growth, 1 is exponential decay. I would like to see the graphs. I would like to see the graphs. No, you have to do the graphs. That's part of the homework. Now, the other thing I want to clear up besides the class and the homework is the class dates. Even if your schedule says you do not have math class that day, I confirmed. Yes, you do have math class. You see the daily video and you do the daily homework. Again, the whole plan is Monday through Thursday, a video, Friday, video conference and practice. And the reason is, again, the schedule is just to keep the classes short in the morning. But some classes do not follow a particular schedule, as in math class, because you have the entire day to work. So you do have math class every day. I confirmed. The second part is exams. Students are asking me, Prof, are there going to be exams? And I want to clear this up. I want to avoid giving take-home tests as much as possible, because if I do give a take-home test, it will be so long and it will be so difficult and it will be timed so strictly that you will not have time to share. Because, a take-home test, meaning this is student math for you guys. Student math. Take-home test equals group test. So in order to avoid the group test part, the take-home test would have to be very, very long, very, very difficult, and very, very strict as far as time goes. So you have no time to share. I would like to avoid that if possible. If I do have to give take-home tests, they will be long, they will be difficult, and they will be strictly timed. So make sure you do every single homework, every single day, to balance out the difficulty of those tests. There might not be a notebook test this quarter. There might not be a project this quarter. There might not be formatives or quizzes. So we're not sure yet how this situation is going to play out until the end of the year. The reality might be that it's just homeworks and tests. And in the test, if you fail the test and you're missing a couple of homeworks, vaya con Dios. So it's going to be difficult. So make sure you do the homework every single day. Half the class did not turn in the homework on Tuesday, and it was a review. It was a heavily weighted homework, and half the people did not turn it in. Not half, slightly less than half did not turn it in. No excuse, they just didn't do the job. Bueno, perdieron pila de puntos. Entonces, again, the homework is very serious. Every single homework is worth a lot, because these might be the only grades besides very, very difficult take-home tests that you might end up with this quarter. Do not miss a single homework. No quiero lloradera, profe, saca un 50. Homework every day. Okay, class every day. Make sure you're understanding. To the students that have contacted me via video conference, congratulations, that's what you have to do. I am here for you guys, even though we don't have a virtual class every day, because I think it's rather pointless and it wastes a lot of time, and you are more flexible. I am available for video conferences on Fridays. The entire day is for that, and any other day. If you don't understand, let me know. If there is a group of students who don't understand, we can get that group together, which is what we have been doing, and I will explain anything, guys. You need to do the homework, and you need to possibly prepare for very difficult tests. And also, if there are no take-home tests and we do go back to school, yay! We're going to have like a week and a half. That's a test, 2 days or 1 day a review, another test, 2 days or maybe 1 day review, another test. It's going to be a very test-heavy week. And I told you guys that at the beginning of this class. So make sure you study every day, because if you leave everything for the last week, you're not going to have time to review a month's worth of class for 3 tests that are given in a single week. Están avisados, and this is recorded. I mentioned this today. I mentioned this at the beginning of class. You have to study every day, because if we get back, it's going to be a lot of tests in a very short period of time, and it's going to be very rough. So make sure you do your daily work, get the job done. The people who have been working, awesome, keep doing what you're doing. Otherwise, any questions, let me know, and I'll see you tomorrow. Take care.